Okay, so today I will be discussing the problem Dreams of Divisibility, which appeared and which was in the January Lunchtime 2021. So the problem says that we are given an array of length n and a number k, and we have to do some operations so that every element will be divisible by k. And the operation which we can do is we have to select two indices I and j, and I can be equal to j as well. So and we have to make ai should be equal to ai plus aj. So we are allowed to do these operations only, and we have to tell that after applying these operations any number of times, can we make the all the elements of the array a to be divisible by k. So we have to print finally yes or no. I mean whether it is possible to do that or not. So um, so first of all, the logic which should come in our mind is that we should bother only for the remainders of k. I mean remainders of the array elements a. I mean ai remainder k is important for us, not the values present at ai, because on addition of two array elements, we just need the remainder. I mean we have to make the remainder to be zero at any cost. So let us suppose we are given an array, and finally let us suppose that it is possible to make the all elements to be zero. So how the remainder array, I mean ai remainder k, will look like finally after applying many operations so that all the elements will be divisible by zero. So it will look something like 0 comma 0 comma 0, and suppose the array has only four elements. So finally it should look like it should something look like this. So now if we will go in the reverse order, I mean what will the one step, I mean one operation before in the last operation. So one element will be non-zero. So let us suppose that element to be x. So x comma 0 comma 0 comma 0. So before applying the last operation, our remainder array should look like this, and here x will be less than k. So now, if we will go back one step before again, so now if we have two elements to be non-zero, suppose, I mean there can be possibility that this element is again non-zero. I mean only this element is non-zero before applying the second last operation. So but there is also one possibility that we have x k minus x 0 comma 0 by k minus x, because this is the only possibility uh, by in which if we add x to it, the remainder will be 0. It's like x plus k minus x remainder k will be equal to k remainder k, and that is 0. So this is the only possibility uh, for which the second element to be non-zero. So now what can be other possibilities? I mean we can make these numbers uh, using this. I mean if so, wait, there is a possibility what can be the value present at this index. So just before this operation, so let the value in the previous step should be, let it be y. So previous value plus other value, that is k minus x, will be equal to the final value, that is x. So y will be 2x minus k. but remember we are showing only the remainder part. So this should be remainder k. So now 2x minus k remainder k can be written as 2x minus k plus k remainder k. So this comes out to be 2x remainder k. So for other index as well, what can be the value present at the index, the second index, just before this this remainder array. So let again y be the previous value at the second index, a1. So y plus other value, that is x, will be equal to the final value, just the one step above value, that is k minus x. So it will come y equal to k minus 2x. So now again I have to store k minus 2x remainder k. So I can again write it as 2k minus 2x remainder k. So this will come out to be 2 times k minus x remainder k. So what can we observe, that all the remainders should be of the form nx or n times k minus x. So these are the only two possibilities. If this is valid, then we can proceed to next step, that or we can say that yeah, there is some possibility that all the elements can be 0. So now coming back to our first step, this, if the value is x, so is it guaranteed that x can okay x plus x, so 2x remainder k will be 0. On applying, so it should be like 2 to the power some x, or no, sorry, it should be like 2 to the power n times x remainder k should be 0, because on adding x continuously we should get at some point of time, that is on dividing it by k, the remainder should come out to be 0. So we should have to check this as well, apart from checking this only. So if so in the first step, what can we do is like we will store the remainder array. The remainder array will look something like this. Here remainder k, and now if we have stored the remainder array, so now we can traverse the remainder array and we can find the smallest ring value. So this will be our x. So now so we have to traverse the ring array again and check whether all the numbers present in the ring array are either n times x or m times k minus x. Whether any of the two conditions is true or not. If both of the conditions are false, then we cannot make all the elements to be 0, because in each time we will get some multiples of the remainder to be some multiples of x or k minus x. So if this is true, then we will proceed to our the next step. The operation, excluding the last operation, what we are left with only x. So on adding x continuously, what will we get? X plus x, 2x. So 2x plus 2x will be 4x, that is 2 square x. So something, I mean, we will be getting in the last sum of, in some of the last operations, something like 2 to the power k. Sorry, k is already mentioned. So it should be 2 to the power l x, where l is an integer. So 2 to the power lx, remainder k, should be 0. So if this is true, then our answer is yes. If this is not, then our answer is no. So that's the logic. So now coming back to code. Yeah, so see, this is the code, and I will be uh, giving the code in the description.